This time, our equation here is already in its standard form, and as you can see, this is really a Bernoulli equation because you could see an expression here, y squared, where n is equal to 2. With this in mind, our p of x is this item here, which is -1, and our f of x is e to the power of x, this given expression here. So we are trying to solve for this Bernoulli equation. It's lucky that we're lucky that this is already in its standard form. The goal here is to find out an equivalent linear equation of this in order for us to solve for the value of a certain variable, which we could relate later on to the value of y. So what we need to do here is, let me copy first the given expression, minus y equal to e to the power of xy squared. We would like this item here, or your side, to only contain the variable of x. Hence, we are going to multiply it by y to the power of -2. Okay, or y, or 1 over y squared. Okay, so y to the power of -2. So this will be removed, leaving this side only e to the power of x. But this affects the rest of the items, such as this. And since this has 1 minus 2 is -1, so y to the power of -1. Okay, so this is already the goal. For the first goal is to come up with f of x only here. Okay, the next thing here is to make sure that this item will only have an exponent of +1. But since it has an exponent of -1, we cannot just automatically change it, but rather we can assume a certain variable, let's say z, be equal to y to the power of -1. And if we do that, this form will become z right now. Okay, it becomes z with the power of 1. So now it's closely similar, or closer now, to become a linear equation. But since you have here this expression, let's try to come up with d of z. This is actually -1 times y to the power of -2 dy, or -y power of -2 dy. What you want is y power of 2 dy. So what we can do here is to divide both sides by -1, or multiply both sides by -1. We will get positive y the power of -2 dy is equal to -dz. So with this now, we can now structure the equation in terms of z in this manner. You have -d of z, you still have this over dx, minus, since this is given as z, so let's use z for that, minus z is equal to e to the power of x. But since this is negative, for the standard form to become positive, let's multiply this by -1. So you have positive dz over dx plus z equal to -e to the power of x. This is now a linear equation. And since this being linear, we can now solve for z, not y, okay? We can now solve for z. Once we are done with z, connect it to this representation, we can now solve for y, which is the main concern of this given Bernoulli equation. So in solving for that, don't forget that we need the integrating factor. So we'll be using p of x, but since p of x already given here earlier, this one here, so to differentiate that, p sub 1 of x is equal to +1, the item here, and you have f sub 1 of x is -e to the power of x. Okay, -e to the power of x. So our integrating factor is e to the power of the integral p sub 1 of x dx, e to the power of the integral 1 dx. So you have e to the power of x, right? E to the power of x. This is our integrating factor, e to the power of x. Let me review. All right. Now that we have this integrating factor, this equation can now be solved. Let me rewrite here the equation again. dz over dx plus z equal to -e to the power of, oh sorry, that's an exponent, power of x. And it could be solved with this expression, mu of x, or the integrating factor, times z is equal to the integral of the integrating factor times f of 1 of x, this here, times dx. Okay, times. So you will have e to the power of x, z, that's our integrating factor, is equal to You have e to the power of x times negative e to the power of x dx. So e to the power of x z is equal to, you will have here negative, I'm taking out negative, so you have e to the power of 2x. Loss of exponents, x plus x is 2x dx. Now to integrate this, we need a certain constant, which is actually, taking out this is negative, e to the power of 2x, we still need 2 here. Okay, because it needs to have that in order for us to really integrate it. But to neutralize that 2, making sure that we are not changing the given, let's have 1/2 here, because 1/2 times 2 is just 1. We are not changing the value of the expression, we're just changing its representation in order for us to integrate this. So e to the power of x z is equal to negative 1/2, and then you have e to the power of 2x plus c. Okay? Now that we have this, we would like to solve for z. So let's multiply both sides by e to the power of negative x, or 1 over e to the power of x, so that this would become e to the power of 0, which is 1. So z is equal to negative 1/2 e to the power of simply x, 2x minus x, and plus c to the power c times e to the power of negative x. Okay. We are done solving for z, but the main goal is solve for y. What was z earlier? This is z. Okay? Z, since z is equal to y to the power of negative 1, this would mean this is y to the power of negative 1 equal to negative 1/2 e to the power of x plus c e to the power of negative x. Let me apply let me just simply apply the rule of the exponent here, because this is actually 1 over y, and we will be reciprocating later. So you have e to the power of negative e to the power of x over 2, that's 1/2, right? Plus, you will have to come up with c over e to the power of x. To reciprocate that, before we reciprocate, take note, this is the sum of 2 fractions, right? We cannot say that the reciprocal of 1 will be equal to all of the time. Let's combine this. Okay, so this is actually 1 over y is equal to negative e to the power of 2x plus 2c over twice e to the power of x. That this is the time it's easier for me to reciprocate that, getting y equal to, I'm gonna place something here. This would be 2e to the power of x, and you have negative e to the power of 2x plus 2c. Okay, so this is very rough. I don't know if I got it right, but definitely this is how it would look like in a certain process. This is our solution for this given Bernoulli equation that we're able to solve passing through z and the concept of linear equation. Thank you very much for watching.